All right, welcome to class today. Before we begin, just want to remind you a few logistics things. This evening at midnight, you have due a game project checkpoint. I believe we're down to just 4 people that I don't have paired up yet, but I think everybody should know who your partner is. Should be submitting one between you. If you both submit, then we'll just take the newest piece of each file, as is described here. Something worth noting is that it was pointed out to me earlier in the week that I had not posted what we expect for the checkpoints. So that is now part of the game project write-up. Notably, checkpoint 1, we want a Python file named game.py that contains at the minimum comments describing your game and how you will meet the optional requirements. Optional requirement is always a phrase that bothers me linguistically, but I think it is the correct thing to say. You're required to do some set of optional things. And so describing how you plan to do that is part of checkpoint 1. We encourage you to also put some code in game.py that will begin moving in that direction. We understand not everybody got started quite as early as other people, but we would like to see some progress here. You'll have another checkpoint after Thanksgiving, and then you'll submit your final game. The other thing to note about this is that unlike our programming assignments where you can submit late for a point deduction, the game will not have that characteristic in any of its 3 submissions. So if you do not checkpoint by this evening, then you'll have to go to checkpoint 2. And the final submission is due the last minute I'm supposed to accept assignments that are not final exams. So if you try to submit after that, I am, per university policy, not supposed to accept additional assignments. I recognize many faculty ignore this policy, but I try to obey policy when I can. So these deadlines are deadlines. You're late, you're not there. You can submit multiple files for these. You just submit them one at a time. They will all go in. As long as they have different file names, we'll get them all. So that is available for you. Questions about the game project? Yes? If you have a music file that... So you can submit files that are more than the Py file, files that you need to be in the directory with your game to play, upload them as well. Please don't give us stuff we shouldn't legally have though. So if you don't have a license to give us some file, then use something else in your game. Other questions? Yes?
So like, if we pull a Stripe sheet from the internet, how do we know if we're allowed to?
So the easiest way is don't pull it, just give the link in your code. Then our code pulls it, your code pulls it, their website let us all pull it, we're good. You can find out what their license was and are you allowed to edit it or so on by looking for the licensing agreement of that. I'm happy to give additional directions if you have a specific question about that. Yes? So if you're not able to open URLs in your game box, there is a fix for this posted multiple places. In the FAQ for the game project, I'm getting an error opening images. This will fix it. This is also at least in 3 Piazza posts now. So far as we know, this only happens in OS X. Are you on OS X? Great. Then so far we have no reason to believe that doing this won't fix it. If it doesn't work for you, please let us know. There may yet be another bug. But as far as we know, this fixes all the cases we found. Other questions? Okay. So we have that coming up. Also, we've mentioned this before, but just to reiterate, there will also be individual assignments due, including an individual assignment that's due Tuesday. So we have those going on as well that will be related to the regular expression things we'll be talking about today. You'll also have a chance to play around some with those in lab tomorrow. So, all of that said, let us sort of remind ourselves where we left off last time. And actually, I should have prepared for this slightly better. Let me do something nope, not that one. Let me do something slightly different and open up some more things that we did last time. And this is going to look weird. Yes, okay, so last class we did a little summary of some various things. Included in what we summarized, we talked about different ways of making regular expressions. Plain characters, character classes, which might include ranges, right, by having the hyphen character in them. They might include the complement of a class by putting a caret in front. We could stick these things together to make sequences. We also talked about repetition, using star and plus and curly brackets and question mark. Each of these turning the one thing in front of them can happen some number of times, depending on which one, a different number of times, but only the immediate thing in front of them, right? So WHE star only repeats the E, it does not repeat everything else. We also talked about alternation, one of two things, with the vertical bar or pipe character. And now we can use parentheses to help bound things and make these things work in other circumstances. Any of these pieces to building a regular expression you'd like me to say more about? Questions you have? Okay. In addition to that, we also showed that there is this tool. No, what's going on? Wrong key. We showed there's this tool Pythex, which can help you write regular expressions, and we'll use that some more today, some more on Friday as well, in order to help us understand an easier way of building out our regular expressions. There are other similar tools online. We found this worked pretty well last time we did it, so we'll do it again. And we wrote a little code. In our code, we had this idea of compiling. We create a regular expression and we compile it into something that can do our finding. And we talked about this idea. What does compile means? It means turn some sort of source code, could be Python code, could be regular expression code, which is what we're doing here, and turn it into something that can run. Right? So we compile a regular expression string into something we can use to do our finding. So we talked about that and we showed how that works. In this example, we showed how we could find course numbers, a sequence of numbers, a hyphen, and another sequence of numbers, so a course section number pair, by compiling this in and finding all of the ones that were there. And compared that a little bit with how the find method works on strings, where it looks for the exact string, which does not exist in this case, instead of for the general pattern. Questions about our code? Okay. Let's remind ourselves what this code did so I can talk about what it isn't doing. And we'll do those other things. Right? So we talked about thing that comes back from finder is this thing that can find in SRE pattern. And the find all gave us this list of strings. It turns out that find all does not always give us a list of strings, and there are other methods that will give us other things. So we're going to talk about 4 of the methods that a compiled regular expression has today. Well, mostly we'll talk about 3 of them. We'll mention a 4th one and mostly talk about it probably on Monday, maybe a little bit Friday, probably not though. So let us talk about what we can do once I have a compiled regular expression. Let's suppose my compiled regular expression is called, I don't know, let's still call it finder, why not? There are 4 methods that are commonly used in regular expression. One of them we have already seen, which is find all. Okay? Find all gives me back a list. And this might be either a list of strings or it might be a list of tuples of strings. And we will talk about how it is different and how you can tell which one it is a little bit, but mostly we won't use find all, we'll use other methods instead that are more consistent in what they give us. We can also ask our finder to find a single thing. Oh, and I should put here, we always have some text in here. The thing we are searching for. Searching through, rather. Okay? So we have find. In addition to find, we have find iter, and we have sub. Are the other methods that we will talk about. So find all, find iter, and sub. Sub we will mostly talk about on Monday. It is similar to strings replace function. It's short for substitute. And it is very useful in modifying strings and doing cool things with them, but fairly complicated because there's lots of extra options with the way regular expressions are built. So we'll come back to that a little later. But today we're going to talk about find all, find, and find iter. So this, I guess, for completeness, also takes the same parameters. Okay, that is not true of sub. We'll talk about that more on Monday. But But these two return something other than a list of strings. Find returns a single thing called a match object. And findItter returns a collection of match objects. These special things that will give us some extra information about what we found. FindItter does not actually give us a list. It gives us a different kind of collection, something called a generator, which we won't spend much time talking about. Essentially, it is good for iterating over in a for loop, hence the iter in findItter, designed to be iterated in a for loop, but not so good for indexing or other kinds of activities we might want to do. So we're going to talk about find first so we can understand our match object. We'll come back and talk about how it works with findItter, and then we'll use it to do hopefully interesting things. So let us just expand on our intro file here and see what happens if we find instead of findItter. So if I ask numbers to find itself in the text and print out M, okay? Notice that this is not the same thing, not numbers, finder, sorry. If I ask the compiled regular expression to find itself in the text, find works backwards from the way it does in strings. In string, I have the text.find, the small thing inside of it. For regular expressions, I have the finder.find itself in the text. And we could argue which one's right and wrong, but that just happens to be the way it is, so we'll deal with it. Oh, and I always name this thing wrong. Why did I do that? I did that this morning and promised myself I wouldn't do it again. It's actually named search. Bother. All right. It's named search, not find. Sorry about that. I make this mistake every semester. Eventually you'll get it in my head that it's called search. Okay, so search. If I ask the finder to search through some text, I get back this SRE match object. And as I look at this, I'll notice a few things. It has inside of it a span, which is a tuple of two ints. These are the indices of the beginning and end of the thing it found. And it also has the string that it matched. It finds only the first occurrence. When I search through, when I find one, I stop. So when I try to search through something, I will find the first one and return this match object about it. But this match object has more than the string, has at least where it was. We'll see it will also have additional information if we have more complicated regular expressions. We can use various methods of this. For example, we can ask for the start and the end of the thing, as well as the group. So start is the starting index, end is the ending index, group is the string that was matched. And so I print those three things out. I can see they're there. And they have the appropriate types, which I can see a little more easily if I print them in a list. So the indices are ints. The thing that I matched is a string. I can see those different elements coming back from methods involved in the match object. They are methods, and I've put them here with empty parentheses. We will see shortly that they have optional parameters that will do other things if we put something in the parentheses. But by default, if we give them empty parentheses, it'll tell us the beginning and end and the contents of the thing we found. So we can use those indices to look around it in some way, or to slice it out of the string, and so on. We can use the group to do something with the contents that we discovered. Questions? Okay, so let's summarize. Our match object had three functions that we might want to use. It has others as well, but these will be a reasonable basis. We have start, we have end. These give us indices into that text argument. Okay? And then there is group, which returns a string that was matched. And so when we get back a match object, usually most things we'll want to do will be some combination of these methods on the match. FindIter gives us a lot of these things. It finds all of them instead of just one, and is almost always put inside of a for loop. So I'd say something like for mn, the finder.findIter of the text, and I could print each of these things one at a time, and I would get them for each of the things that was matched. And so I will see, I first have the one that I printed before the loop, then I have the first, second, third, and fourth, starting and ending index and value that I had in my string, because there were 4 of them there. Questions, thoughts, comments? Okay. I'm going to change exactly 1 character in my code. I'm going to change that dash to something else. Let's change it to, how about a W? So I changed the hyphen that was in my regular expression to a W. What will my program do when I run it? First off, what does this regular expression match? What kinds of things, what's a value that this would match against? Yeah. Yeah, I would need digit, 1 or more of them, a W, and another digit. So something like 3W7 would work fine. Or 368W52 would also work. Do we see any of those up here? No. So I don't expect to be able to find any. And yet I am asking to find them all. I'm asking to search for one, and I'm asking to iterate all of them. So I'm asking to find these things, and I don't expect to find them. So I run it, and let's walk through what it does. First off, when I compile it and print it, it compiles and prints just fine. There's nothing wrong with this regular expression. But when I ask to find all of them, I get an empty list. A list of all of the matches. There were no matches, that's the empty list. Okay? Which is a sensible response. If I ask you to tell me all of the things that are there and there are none, I say there's nothing. So that's a reasonable response. Let me comment out this line because it's not really about regular expressions. Okay? When I do the search and print that out, I get a none. So when I ask to search, instead of it giving me a match object, it gives me nothing. Because there was no such match. It couldn't find it when it searched, so it gives me back none. And then, on the next slide, when I ask m.start, I get an error. Attribute error, none type object has no attribute start. You can't ask start of none. You will probably see this error message several times as you're going along writing your own regular expressions. If you write a regular expression and you can't find what you're looking for, and you try to do something with the match, you will get this sort of none error. To guard against that, I probably, if I really want to use search, I probably want to say if m is not none, then do this stuff. I have to manually check. This is actually officially not the best way to check if things are none, but we won't talk about why there's a better way to check if things are none. This will work fine, although it will give you a little gray squiggly underline when you type it. That's fine, you could ignore it or see what it says. So I only print if it's not none, and then I won't print it. And I also don't print anything down here for my FindIter. FindIter also returns a collection like FindAll does, and it gives me an empty one. And if you try to do something for everything in an empty collection, you do it no times. So FindAll and FindIter will sort of deal with it wasn't there naturally by doing nothing. Which may or may not be what you expected. So you may, if your code should be producing something and isn't producing anything, a likely case is that you wrote your regular expression or the thing you're looking through in such a way that it can't find any of them. Questions, thoughts, comments, concerns? Okay, I'm going to change this back to a hyphen So that will be the version that will go up on the web when I upload this at the end of class, so that we can actually see all the things in it. So we have our match that comes back from search, a match set that comes back from find iter. We can also find all and get a bunch of strings. We have yet to see how we'll get tuples. We'll see that here in a moment. So these are how we use these things in code. This leaves out one of the fairly useful feature of regular expressions, which is the ability not just to find things, but to tell me details about what it found. So let's explore that a little bit in Pythex. Let me grab, let's grab this same basic bit of information. Use that as my example text in Pythex. Okay. And let's write that same regular expression we just had. Let's make it more explicit though. Let's say I know that a course number section number is always going to be digit 0 through 9 exactly 4 times. So between 4 and 4 times, a hyphen, and then digit 0 through 9 exactly 3 times. Between 3 and 3 times. And so I can write this regular expression that will find those 4 things. But this really has multiple pieces of information. There is the course number, and there's the section number. I could also argue that the digits of course numbers are individually supposed to mean something. It's unclear if they really do. But we could try to piece this apart. And while I find all of these, and I could then, split them on hyphens or something to get out the extra information, regular expressions often want us to find bits and pieces of what's going on. And this is made available as a second thing that parentheses do. If I put parentheses around the portion of my regular expression that matches the course number, I will see over here in the left, I'm matching the same things. Over here in the left, it tells me those course numbers as the matches. Okay? For each of the searches, it tells me what it matched. So there is this idea in regular expressions of what's called a matching group, or a capturing group, or a match. This idea of taking a subpart of my regular expression and telling me what that subpart was in the context of the larger regular expression. These are created by opening and closing parentheses. Whatever was matched between an opening and closing parenthesis pair shows up as one of the matching captures that we found when we found our thing. And we can have as many of those as we want. So I could, for example, also put a parenthesis around the section number. And that will come in as the second thing that we found in the match. I can even put one inside of another. So I see I have 3 sets of parentheses in my regular expression. I get 3 captures. And these 3 captures are ordered based on the order in which the opening parenthesis appears in the regular expression. So the first opening parenthesis is around the section number, so I get the course number, so I get the course number. The second opening parenthesis is around the dash and the section number, so I get the dash and the section number is number 2. The third opening parenthesis is around the section number by itself, so I get the section number by itself as the third thing. So when they're nested inside of each other, like I have here, the opening parentheses tell me what order they will appear in my matching captures. Questions so far? There's another odd detail that might or might not be worth mentioning here, but we'll try it anyway. If I put parentheses around something that is itself repeated, like the 4 digits that make up part of the section number, you'll notice my match is 0. I put the parentheses around a regular expression that can only match 1 character. So my capture there will be 1 character. This particular part of the regular expression, when given this string, matched a 1, and then it matched a 1, and then it matched a 1, and then it matched a 0. And I see that last one. The last thing that was matched is the thing I see. So for 1110, I will see a 0. For 1111, I will see a 1. It will show me the last character that was matched, or the last time that this group was matched. It is relatively uncommon to want that behavior. Usually if something's being repeated, I don't really want that match, but it will show up in what I see, so it's worth understanding that it is one of the captures that appears. But we probably don't want it, so let's get rid of it for now. So, we have this ability to use parentheses to group things, to get captured groups out of it when we look at it. In Pythex, we'll see how to do this in Python next. Questions so far? Okay, let me just take this exact regular expression and let's make us a new file. Let's make a new Python file. I will say this will be using groups. Let me grab from my previous, let me go ahead and paste this so I have it. We'll put that together in a moment. I'll grab the same text and import that I had before, because I always want to import regular expressions, and that's a fine piece of text to taste things with. So I have a regular expression, I have the text. Usually when I make regular expressions, I will make them directly. So I will make my finder, let's call this course, why not? My course is going to be re.compile, and then I'm going to compile the string that I want to match. Now, there's something interesting here that PyCharm does. If you put a string inside of re.compile, Python will recognize that the contents of that string should probably be a regular expression, and will highlight them not like a string. It will not show up entirely in green, it will show up each individual little piece, or the greenish cyanish color they use here anyway. It will show up each individual piece as having some meaning, to try to give you some feedback if you did something that you didn't expect to do in your regular expression. So I can compile that, and let's just do a find iter, because that's usually what I find myself wanting to do when I'm writing regular expressions, is to find all of the matches with all of the information about the matches along the way. And let's just print m.group for starters. And I will see it finds the same 4 things. This shouldn't be surprising, it's very similar to what we just had. Okay? Looking for some number of digits, a hyphen, some number of more digits. However, at this point I can start getting at using the optional parameters that I have inside of these methods, the group start and end. So if I ask for group 1, then I will get the first capturing match, the contents of the first set of parentheses. And if I ask for group 2, I will get the second one. And if I ask for group 3, I will get the third one. So I can put an integer inside the parentheses to get that group match. Notably, we start at 1, not at 0, because group 0 is defined to be all of it. If I spell group correctly. So group 0 is the entire thing, with or without parentheses. Group 1 is the first set of parentheses within it, or the contents of the first set of parentheses. And group 2 goes on from there. We can also find out what all of them had by using the groups function, or the groups method. Will give me a tuple of all of the captures that I had in my regular expression. So I want a tuple, I can do it that way, or I can get them one at a time by using the group with an integer inside of it. So I can extract this information. Thoughts, comments, questions? Yes?
What does the line print.m.group print?
Print m group printed this. You're welcome. Yes?
What do the curly braces do again?
The curly braces are one of the 4 ways of repeating something. It means repeat it between the first number and the second number. So I put 4 in there twice, I'm going to repeat it between 4 and 4 times. which will always be 4 times. So keep it from matching 3 digits or 5 digits. It will only match 4. Other questions? Okay. So, matches have this extra power to be able to pull out their groups. And that's part of the reason why matches are generally more useful. It also prepares us to explain how find all works. Find all will return a tuple, the same tuple that's returned by groups, if there are any parentheses. But if there aren't, it will return a string, the same string that is returned by group, without the S. Okay? So, we've actually seen the returning the same string that's returned by group over here. When we ran this code, we saw that find all gave me a list of strings. The strings that would be returned by group with no numbers in it. If we do this same thing in a regular expression that does have parentheses, I will see it does not return me a list of strings, it returns me a list of tuples. And those tuples are the tuples that are returned by the groups. So if there are parentheses, find all gives me tuples of what they matched. If there are not parentheses, then it does not. Because of this, I almost never use find all. I mention it mostly because it's the book's favorite thing to use. So if you read in the section on the book about regular expressions, which I encourage if you're finding them in any way confusing, or even if you're just curious about what the book says, it has a reasonably good explanation of how they work and some other details about them we won't go into, about other things you can backslash and so on. But it uses find all, which will give sometimes tuples and sometimes strings, because that's how find all was defined. Thoughts, comments, questions? Okay, let's see an application of this. So far I was just playing around exploring how it works. Let's see using this to do something maybe tangentially interesting. So I'm going to make myself a new Python file where I'm going to, I don't know, we'll say, we're going to try to parse a web page. We're going to open a web page, read through it, and we're going to look for various linguistic or grammatical things on the web page. Okay, so we will see how many we get to. But the first thing, we're going to read a page and find the words that follow articles, where an article in English is either a, an, or the. So we're just going to try to find these words. In English grammar, typically a noun has to follow an article, but sometimes it can have adjectives or adjectival prepositional phrases in between. So, well, anyway, we'll go through and see what we can find. We may add some other tasks as we go. This will, of course, involve importing regular expressions, because I need regular expressions. I also have to import urllib.request, because I'll be reading from the web. And so we'll have to sort of build both reading a web and making a regular expression. Since we've been talking about regular expressions lately, let's remind ourselves how we read from a web page. Let's decide what web page to use. Why don't we use the game page, because I happen to have it open. So I'll use the game project definition. So I will say the page is urllib.request.urlopen that URL. And then let's say for every line in that page, the text of that line is the line decoded UTF-8. Oh, I don't know, why don't we strip it? We usually strip things, that'll be fine. So I'm going to open the page for every line, I'm going to get the text out of the line, and then I'm going to look for articles next. So, before I talk about building this regular expression and going forward, anybody want me to review any piece of reading the web? It's been a couple weeks since we've done this. Okay. So open a web page, I read all of its lines, now I need to look for articles. This means I need to build a regular expression. I find it easiest to build regular expressions if I can test them as I go. So let's go to Pythex and build ourselves a regular expression. Oh, but I better have some text to play with. So let me grab some random text. Okay, wrong tab. Here we are. Nope. So I'll put this in the text. It does look like there's at least a the in here somewhere. And there's an a, that's good. I don't see an an. So I'll just add some more text so I have some example to play around with. Doesn't really matter what the example is, as long as it has the things I'm looking for. So let's start by just saying, if I want to find things after an article, I better find an article. So I need to find a capital or lowercase a. That's an article. But it's finding way too many of them. It's finding ones that are in the middle of words. So let's say, okay, I want a capital lowercase article followed by a space. That's doing a lot better. But it's also finding things like via and UVA. So let's put a space in front and at the end. Now I'm finding space a space, which is the a as a word. It is not every way a could be a word. It does not, for example, deal with the idea that an a might be the last word of a sentence. Oh, that's pretty unusual. It also doesn't deal with the idea an a might be the first character after a new line. So it's not perfect, but it'll be good enough for what we're trying to do. So that catches a's. But I also want ands. So I have an option. I want something separated by spaces, but I want it to be an a, or maybe I want it to be an an. And so now I'm just looking for space, letter space, where maybe it's an a, maybe it's an an, or maybe it's a the. And here I have the articles. As words, because I have it surrounded by spaces, any one of the three articles I want. Thoughts, comments, questions? Yes?
Is the big vertical slash kind of like a or statement?
It is. Other questions? Yes?
How do you have it surrounded by spaces? Just
I put a space here, and I put a space here. They're hard to see because they're spaces. Other questions? Okay. What I really want though is the word that follows an article. So I need, after this word, the a or an or the, I need a word. And words generally consist of a bunch of letters. A to Z, A to Z. Probably more than one of them. And now I have the preceding, a different, the exam, an extension, the above, a good. Hooray, making some progress. This, again, isn't a complete match of everything that could be a word. It won't deal with hyphenated words or words that have apostrophes in the middle. So it's not the perfect way of doing it, but it's a reasonable way, and we won't spend the effort making it perfect here because it becomes increasingly complicated as you think of more and more special cases. So I have this way of matching a word following a, an, or the. It misses a few a, an, or thes, it misses a few words, but it mostly catches it. Question?
What's the reason behind putting an additional sign at the end of most of these?
Great question. What does the plus sign do? Plus sign means one or more of these things. So I'm saying, by saying a letter plus, I mean I want at least one letter, don't give me none. And if there's more than one letter, give me as many as there are until you bump into a non-letter. Other questions? Okay. When I look at my matches though, I see the article gets matched because I needed those parentheses to use my or correctly. But the word doesn't. So if I want to add a match, I just need to put a parentheses around the thing I want to have matched. And now I have two captures for each match. I have the and preceding. I have the and exam, a and different, and extension, the above, a good. So I now have one of those captures is the word that I was interested in. So I've now built a regular expression that should be able to help me find the things that I'm looking for, the words that follow articles. Since I have a working regular expression, I'll just copy it. And I'll go back over to Python and I will make me a regular expression for it. So words is going to be re.compile that regular expression. And I will assume if it worked on Pythex, it will also work here. Assuming I copied all of the characters and not just a subset of them and not something I shouldn't, that should always be true. And then inside my loop where I'm looking at a line of text, I now want to find all of the matches of this inside that line of text. So I can say for match in my words.findIter of that line of text. So my loop first is looking at every line of text in the page, and then for each of those lines of text is looking for all of the words as defined by my word thing, an article followed by a word. And then what I'm interested in is the words that follow the article. So I'll do m.group2, group not goop. Because the first set of parentheses is the article, the second one is the word that follows the article, that's the word I'm interested in. And when I run it, it lists out a bunch of words. Are these the right words? To really know this, I'd have to go look through the website and see, does it indeed say a partner or the partner? Does it say an entirety or the entirety, and so on? I'm not going to spend that time because I want to get a little past that today. But I should probably check that I'm getting them all, verify that my regular expression is working in some way. But we're going to trust that it works. Question?
I've got some red squiggly underline near the end of the capital A-C.
Yeah, so that means you didn't do this correctly somehow. Red squiggly is it trying to tell you that you typed something wrong. And I couldn't tell you from here what that is, and I don't think we have a TA in the room. No, we do not have a TA in the room today. Other questions? Okay. Let's, to keep it for printing lots of things so we can add another thing, let's make an after article list, and instead of printing them, let's append to the list. And then let's just print out the list all in one line when I'm done. So I can get a list of all of those words instead of having them one at a time being printed out. All right. So I can find all of these things, grab the right group, put them in this thing, and now I know what all of these words were. Let's look for another thing. If I look at that website, I will see that it has a lot of parentheticals. Right? You should work with one partner. 9th November, or an adjacent class for 1111. Worth more points, see the syllabus, and so on. So let's just try to find all of the text that's in parentheses on this page. To do that, I'm going to need to make myself another regular expression, one that will match things inside parentheses. So let's go here. Oh, but let's give ourselves, so we have one parenthetical statement in here. Let's make another one at least. Another parenthetical and a third. And we can use this same text to try to find parentheticals. So I know that I want to match an opening parenthesis to find a parenthetical statement. So I'll write an opening parenthesis. I have an error. Invalid regular expression, unbalanced parenthesis. A parenthesis is a special character. So I have to say I want an actual parenthesis, not the beginning of a group, by backslashing my parenthesis. So I mean a parenthesis character. Then I want some stuff. And then I want a closing parenthesis. Uh-oh. This is not looking great. It's not finding one parenthetical, it's finding from the first opening through the last closing parenthesis. I can see that more clearly if there's something after the last closing. Because dot, the period character, matches anything, including closing parenthesis characters, which I didn't really want to be part of my parenthetical. So I can't say a dot, I need to say, instead, I don't want a closing parenthesis. And now I say I want an opening parenthesis, anything other than a closing parenthesis, any number of those, and then a closing parenthesis. And now I'm finding parentheses. But I'm not quite done because I want the text that's inside the parentheses. So I need parentheses around the text that's inside the parentheses to find the text that's inside the parentheses. Oh, but I need it on the outside of the star. And so now I have my regular expression, which is completely obvious what it means, right? Backslash open paren, open square bracket, caret backslash close paren, close bracket star, close paren, backslash close paren. It's obviously what we need to write. Regular expressions very quickly look very strange. Okay? And so you almost certainly want to build them a little piece at a time. Add one thing, fix it, add another thing as you go along. We'll talk about some other strategies for this on Friday. But let's just reiterate. Backslash open paren means I want an opening parenthesis. This set of parentheses means whatever comes in here is going to be grouped together so I can get at it later. Then I say I have a character class. It starts with a caret, which means it's a negative character class. It's things I don't want. I don't want a closing parenthesis. And I want as many not closing parentheses as you care to give me, from 0 on up to infinity. I don't care. That's the end of the group, and it needs to end with a closing parenthesis. So this is my regular expression to find parenthetical statements. Short, but a whole lot of the same character in different orders to be confusing. So I can make my parens can be re.compile that regular expression. And then I can look, after I've looked for the articles, I can also look for the parens dot find iter of the text, and let's just print those out. And that was the first match, so I'm going to use group 1. And I see that it says the things I have parenthesized or in an adjacent class for 1111. See syllabus for details. Based on the current Archimedes submission, and so on. These seem like possible, reasonable things that could actually be in parentheses. I should check the website to make sure. Questions? Yes? Why am I using group 1? Because over here, it told me that match 1 was the contents. Or, if you want to think of it differently, the first opening parenthesis that wasn't a character opening parenthesis is the one that contains the text. Other questions? Okay. One more thing I want to make sure we get to. We probably won't quite finish it, but hopefully we'll get far enough that you won't be confused when things happen. Let's talk about the annoyance of the backslash. Let's suppose I have some string. Let's suppose this was a some sort of file path on a Windows system. Okay, so it has backslashes in it. And if I print this out, it does not look right. I see C:\/ program files, big gap, his is a test, exe. Because backslashes are special in strings, and so /t is a special thing, and it becomes a tab. But /p is not a special thing, so it stays a /p. Which is not probably what I wanted. To actually make it a backslash, I have to // it. Okay? So I can // it to say I want C program files, this is a test, that is what I wanted to see. So I have to backslash my backslashes inside of strings. But it gets worse. Let's suppose I want a regular expression that finds backslashes in the things after them. So I can compile a regular expression that is a backslash and the thing after it. 2 backslashes to make it a backslash, and then I can print t.findAll inside of S. And it finds a period, because backslash backslash turns that into a backslash character, and then that's a backslash period, which finds me a period. So to actually find a backslash backslash and then anything, I need a backslash 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 backslash. Ah! Horrible. Okay, there's a special kind of string designed specifically to make this less horrible. If you put an R in front of a string, it will not require you to backslash backslashes. It will treat them like backslashes. So if you need backslashes in your regular expressions, you probably want to use an R string instead of a non-R string, so you can write half as many backslashes. We'll talk some more about that on Friday. I will see you all on Friday.